Introducing aPriori.
Hello, and welcome to Design for Sustainability, where we'll be taking a look at a number of different ways in which you can reduce the environmental footprint of your product designs. My name is Mark Rushton. I'm part of the product marketing team at aPriori. I'm responsible for the design engineering and sustainability products. My background is engineering design, and I've spent the best part of 2 decades involved in product development, namely 3D CAD and additive manufacturing. Sustainable design is a very broad term and one with many different definitions depending on where you're coming from. So I'll spend some time on what it means to us at aPriori. The same is true for the definition of a sustainable product. This will be different for almost everyone watching, so we'll touch upon that in this session as well. Then we'll take a look at the importance of benchmarking. This is critical if we want to avoid being accused of greenwashing, and also if we want to meet our sustainability goals. Then we'll dive into how we can start to lower the carbon footprint of our products and product manufacturing. Knowing where to start is crucial. Then we'll look at the impact of materials and manufacturing processes and how they contribute to greenhouse gas emissions. And we'll finish up with how aPriori can help deliver the insights you need to go from intent to action towards your sustainability goals. So why are we even talking about sustainable design today? Well, for one, it's the right thing to do. The climate is getting hotter, and scientists say we're close to a point of no return. Customers and consumers are aware of this, and they're demanding more sustainable products, but they're also willing to pay more for it as well. Investors are also applying the pressure. They know that there are several risks with businesses that are not on the right path, and so money is much harder to come by unless you have a good sustainability strategy. And lastly, legislators are also turning the screw. We have seen the EU and the UK, among other countries, set dates for when compliance to these rules will begin. And the SEC in the US has also made proposals for similar environmental reporting. And we're seeing results of these pressures transferring into long-term business goals. These are results from a 2022 survey showing what is driving sustainability efforts. And you can see consumer demand is very high on the list, as is the internal goal of reaching net zero. Another reason to look at sustainable design is that we're currently using more resources than the Earth can replenish. This year, Earth Overshoot Day happened on July 29th. We simply can't use this much resources any longer. The effects are evident by now. This is a picture of the Cory Calice, which is the largest outlet glacier of the world's largest tropical ice cap, the Calcea ice cap, which is high in the Andes Mountains of south-central Peru. This photo is from 1978 in July. The glacier was still advancing at that point. By 2011, the glacier had completely retreated back onto the land, leaving a lake of some 86 acres in area and 200 feet deep. And this is the same location in the same month of 2011. And unyielding drought conditions in the southwest US have taken a toll on Lake Powell. It's currently at just 26% capacity, and Lake Powell is the second largest reservoir in the US. This image is from August 2017, and compare that with this image just 5 years later, also in August 2022. So some quite shocking images, and I'm sure you've seen lots of those before, and I'm sure you're aware that also greenhouse gas emissions have been growing rapidly, as have global average temperatures, with a notable dip in 2020 when we all stayed at home for most of the year. Further proof, if needed, that human activity definitely has a part to play. But it's not all doom and gloom, because recent history actually shows we can work together and take action. In 1987, the Montreal Protocol was agreed, and that successfully led to phasing out of 98% of ozone-depleting substances compared to 1990 levels. And most of those substances were also potent greenhouse gases too. So we know we can work together to protect the environment. So let's lighten up a little bit more. Hopefully we have some fans of The Office. This is from the US version of the TV show. If you're not aware of it, it's a comedy TV show featuring a fictional paper company, Dunder Mifflin. And back in 2011, they found themselves in an increasingly competitive market, struggling to differentiate themselves, and employees and stakeholders wanted to know what the plan was. And Michael Scott, the regional office manager from the Scranton, Pennsylvania branch, took it upon himself to announce what his plan was.
We're going to come back with a plan for you. It's a 45-day plan. 45 days to get us back on track. 45 points. It's a 45-day, 45 point, 1 point per day. We get to 45 points. We're back in business. And you can take that to the bank. And limo lady, we're going completely carbon neutral.
So there you go. Getting very carried away there, and you just can't say that today. People are aware of greenwashing. Many companies have made commitments like that, but now is the time for action. And perhaps your company has a strategy, but McKinsey found that although many companies have defined a strategy, and up to all of them in some industries, less than half believe they have the knowledge to do so. And it's not surprising. It's an incredibly complex area. It's not like cost even, where you can take an educated guess at which design is cheaper. With sustainability, in many cases, the decisions will be massively counterintuitive. And there are a lot of terms thrown around. I quite like this definition, as it quite clearly differentiates the different approaches. But there are lots of different definitions, and we want to be able to help with all of them. So the first one, sustainable design, is the broadest possible term. It looks at both the social impact as well as the environmental impact of developing products. Then there's eco design, which is purely focused on the environmental impact. And it's really about decreasing the footprint as much as possible. And then there's a third approach, which is circular design. And that's really about reusing the materials and resources as much as possible. But unfortunately, it's not a perfect circle because there will be some leaks in the system. And that doesn't look at reducing the footprint. It's more about reusing the content. So it's not about making the footprint as small as possible. So it's more about resource efficiency. So next, it really begs the question, what are we looking for, and how do we measure, and how do we become a sustainable company producing sustainable products? So Trevor Zink and Roland Geyer actually believe there's no such thing as a green product. And a better approach is about measuring the overall net green impact. And to do that, we need to choose the right benchmarks. And the trouble with benchmarks is just deciding what the right ones are. Is a hybrid SUV a greener product if the consumer was considering an internal combustion engine SUV? But what if it's a second car instead of taking public transport? Depending on what you're comparing it to, it might not be quite as sustainable as you originally thought. And all products have some environmental impact, whether that's raw materials, production, in use, end of life, or even intermediate products such as electricity from natural gas. Compared to coal, it might be pretty good, but compared to renewables, it's much worse. So choosing that benchmark is really quite critical. And then what about packaging? That's something that gets a lot of attention. If we compare recycled packaging to packaging made from virgin materials, that might show some improvement. But what if we don't need the packaging at all? It's really complex to be able to make these kind of benchmarks and comparisons. And luckily, aPriori is particularly good at helping you make these decisions and compare them with previous designs or iterations of the current one. And design holds the keys to the majority of products' environmental impact. Much like cost, 80% is decided at the design phase. And there are a number of ways to assess it. The first is life cycle assessment, and that really covers everything from cradle to grave. Another approach, if you're looking at circular design, really looks at cradle to cradle. And cradle to gate is where design and manufacturers really have the most influence. And you can measure all of these with life cycle assessment tools. But the trouble is they usually look at things once everything's finished. So they're not very good at helping us make decisions unless it's a completely new generation of the product. They look at how much material is used in the product, not how much is bought and actually used in the manufacturing process. And it uses a lot of industry averages, and they can take weeks to create and deliver. And we need to make decisions in minutes about our designs. We can't wait weeks and we can't wait till it's finished. But first we need to measure, and an organization called the Greenhouse Gas Protocol sets the standards to measure and manage these emissions. It's an accounting standard for companies. And the way that's done is with 3 scopes. And this is a really good way to visualize where the emissions are that you need to be aware of in order to control them. And as a design engineer or a manufacturer, it also allows you to focus on what you can control. And the challenge really lies in scope 3, which is kind of suppliers and the in-use phase of the product, among others. Now, we know the options or variables that we can affect, and each one has got a different level of effort and a different level of potential impact. Much like when you're trying to get the cost down of an assembly or the weight of an assembly down, you look at where the biggest contributor is. You look at the biggest cost, the most expensive part, or you look at the heaviest part first to try and make some savings. And it's really the same with CO2. So one thing we can do, we can create our design, and then we can look at where we're manufacturing it. Based on the location and the local electricity mix, which is how the electricity is generated in that region, that's going to have an influence. So if we look at somewhere that uses a lot of renewable energy, we could actually make some savings over somewhere that uses a lot of coal or carbon heavy electricity generation. But that's quite late in the phase. We're not going to be able to make any design changes. We're not going to be able to really make any material changes by doing that. And so our potential for reduction is quite low. So we could move the process forward a little bit, or take a step back and look at changing how we manufacture the products. So in that stage, we might be able to change the material to one that has more recycled content, or a slightly more a slightly lower carbon material potentially, to make a change in the manufacturing process. We might be able to make some minimal design changes to reduce the carbon footprint. But again, we've got a little bit more flexibility, a little bit more potential for reduction of carbon footprint, but not a huge amount. If we start from design and take a holistic approach, we can change a lot more. We can change the shape, we can change the material, we can change the manufacturing process, and we can consider changing the sourcing location, all based on what's going to give us the best result. So that's really where we're going to have the most potential for reduction. And this is very analogous to cost. If you think of this chart, I'm sure you've seen it before, where we've got design freedom. As we progress in our project, that reduces as we get closer to manufacturing. And any changes that we make along the way, the cost of those goes up. And design freedom is really the same as our potential for CO2 equivalent reduction, which is why aPriori is so well positioned to help in this area. So let's take a look at changing our manufacturing location. What exactly makes a difference here? Well, the electricity generation is really the key driver for the manufacturing process CO2 equivalent emissions. And you can see here data coming from our data partner EcoInvent. You can see it has quite a big difference from the amount of carbon CO2 equivalent emissions for generating a kilowatt hour of electricity. So you can see the Quebec region in Canada and Norway use a lot of renewable energy, renewables to generate electricity, and so their CO2 equivalent emissions is quite low. Whereas South Africa, China, and Australia use a lot more carbon-heavy methods for generating electricity. So that's one way we can look at where we get the parts sourced from, and where we do the manufacturing. That's going to have some effect. So then we take the next step forward, which is changing how we manufacture. So we're looking at materials and processes. Well, material really is the biggest driver, but that does go hand in hand with the manufacturing process. If there is a lot of material wasted, it's essentially lost carbon. So we're not going to get the benefit if we are using a particularly wasteful manufacturing process. The material utilization really does play a big part, which is what aerospace calls the buy-to-fly ratio. And just to give you an idea of a better sense of how much materials contribute, here's an average material contribution compared to each process group. You can see stock machining being the highest because of that typically high wastage amount. Die casting, it uses a lot more of the material, but it's slightly higher energy. So to actually do die casting, so you can see the material plays a slightly lower percentage. And plastic molding, again, slightly lower energy to do the plastic molding. So material plays a slightly lower amount because it's also less wasteful production method. So without considering CO2, material selection is complex anyway. You know, how much choice there is, there's a lot to choose from. The availability, how much do we currently buy? Is it a recyclable material? Can we use secondary materials? What's the durability like of that material to make sure that we've got the right performance for our products? If we choose a different material, is the density different? Is that going to give us a much heavier product or a lighter product? Is that going to do the job still? Then what about water and how much water is used in the production of that material? Or and of course cost. Cost is always going to be a consideration as well. So because it is so complex, we're not going to be able to improve things across the board. So we really need to do some trade-off analysis and decide which compromises we can make in order to get the best balance between environmental impact and ensure that we can still be profitable. So if we start at design, start with a clean sheet, that's really where we're going to have the most success when it comes to getting the right balance between cost and carbon. Really, we want to take a holistic approach in order to do that. So design holds the key to a much more sustainable product. And the way I like to think about it is a mixing desk in a recording studio. Every lever that you change, all of the dials, they're giving instant feedback. So you can play around with these variables and get instant feedback as to what sounds the best. And that's very similar to design. We really need that instant feedback so that we can tune our design to get the best product performance, make sure it's manufacturable, and make sure we've got an appropriate cost and as low CO2 equivalent emissions as possible. And we need reliable and fast feedback to do that, to make sure that we're not affecting our time to market. Now, we know material is usually a majority contributor, but it cannot be the sole focus, because sometimes actually a higher cost, higher performance, higher CO2 equivalent material could actually provide us with a lower overall cost and a lower CO2 equivalent, believe it or not. Because the shape or the thickness can be influenced by the material, we could get away with a maybe stiffer, stronger, more expensive material, because we can use less of it. And if it's got a different cycle time, then that's going to affect our processing emissions. So there's a lot of balancing acts that we can do to achieve the results that we're looking for. When it comes to the manufacturing process, we really want to focus on material utilization. Any wasted material is essentially wasted carbon, but also process time can have a big effect on that as well. If our processing time is short, that's going to have a much lower impact. And then lastly, manufacturing location. If that's all we can change, then great. Sometimes we're not going to be able to change it, but luckily that has quite a small impact. But it does depend on both how intense the manufacturing process is and what the material considerations are. So how can we balance all of those things? Well, we want to make sure the product performance is there. That kind of goes without saying. And to do that, we can look at the shape to make sure that we've got the right form to deliver the performance that we're after. And that goes hand in hand with our material choice. And both of those influence the manufacturing process, or rather the manufacturing process kind of influences where we can go with shape and material for manufacturability. So they all kind of play off one another, and getting fast and reliable feedback on how you can use all of these three together is crucial when you're making those decisions. So then we've got all of those things considered, we can then look at the manufacturing location, because by making certain choices, we might limit our options there. If we're choosing a manufacturing location first, that's going to feed back and make us make some decisions around the manufacturing process and shape and material. And all of those things are what impacts our cost. So we need to consider all of those things together to work out what our cost is going to be. And all of those things also lead to our CO2 equivalent emissions, but not in the same way. Somewhere that might be a lower cost is probably not going to be lower CO2 equivalent emissions. So it's a real balancing act to get it right. And considering all of these things together is really what's going to put us in a very good place for both sustainability and profitability. And that's where aPriori comes in. So every change you make is going to be quantified with a cost and a CO2 equivalent emissions value. So when we're at the design phase, we can make sure it's fit for manufacturability, and we can compare different manufacturing processes very effectively and very quickly and ensure that the design is fit for the process. We're also going to be given a CO2 value and a cost value. So then we can make sure our design is fit for the process. Then we've got material selection. We can very quickly go through different materials, evaluate them for both cost and CO2, and make sure that we're trending in the right direction. Then we want to make sure that our manufacturing process is feasible. Can we actually do what we want with that material and that design? And we can also get a sense of how much material is used and what the utilization level is like. So then we've got our first three things sorted. We can then go off and look at different suppliers, and based on where they're getting their electricity from, that's going to have some impact as well. And all of those things we can do with full visibility into cost, so we can make sure that we're still being profitable. And as you're probably aware, aPriori's 3D CAD-driven analysis engine provides configurable, precise results based on manufacturing intelligence and the latest available data. And we're adding on top of that environmental impact data from EcoInvent. So not only will we be calculating cost, but now also CO2 equivalent emissions. So it's my pleasure to announce aPriori Sustainability Insights, coming with our next major release, which is expected in March 2023, is Sustainability Insights. Featured in AP Pro, AP Design, and AP Analytics, it's an additional value and breakdown which will be calculated for each product scenario, which is going to empower your product teams with the data they need to ensure profitability and sustainability without harming productivity. So what are we going to be able to achieve with this? We're going to be able to identify low cost and low carbon suppliers based on their location. We can evaluate the carbon emissions of alternate design specifications in different materials, which is going to allow us to iterate more, try alternate designs and different materials. We can also try different manufacturing processes to see the effects on greenhouse gases. And the design, the material, manufacturing process, and local electricity mix generation can all be evaluated together with full visibility into cost and ensuring manufacturability. So balancing all three will ensure that you can deliver best-in-class products on time. By being here, you're already on the right path. Working together, we can solve the biggest problems. History has proven that. And the data is at our fingertips. We've had more data than ever before, and we need that to make the right decisions. And taking a holistic approach is how we're going to make the biggest strides forward. And here at aPriori, we want to help you by integrating the data-driven insights into your existing workflows to allow you to iterate more and reach your sustainability goals. It's been my pleasure to talk to you today. Thank you very much for watching.
aPriori, making profitability and sustainability a reality for a better world.